Hello friends, today we will discuss uh, the first topic. The lecture is set theory. Now what is a set theory? The basic definition says a collection of well-defined objects or items. Okay, so well-definedness, this is the basic thing. So if you can define a item or an object in a group with some property, suppose it is a chair or table or boy, girl, height, width 5 feet 2 inch or something else, okay, or even number, set contains the even number. So I can write the within the sets the elements will be 2, 4, 6 and so on. So these are the things that will come in the set. Okay, so well definedness means you have to give a property, you have to identify a property in a group of items. Now how to write a set? Okay, set is written within the parenthesis. So you can, if I have these elements, suppose a, b, c, so if I write this a, b, c, these are first three letters of the alphabet. Now if I write this one, okay, there are other bracket options we have, or angle bracket. Then these three representations are not considered to be the set. This is a set because we have used this parenthesis. Okay, you have to write these elements in this form. So these are the elements a, b, c separated by comma. Okay, now there are two types of representation, set representation. One is tabular and another is set builder. Set builder. Now what is tabular form? Tabular form includes, if you list the elements, suppose you have a set of even numbers, so I can write like this 2, 4, 6, 8 and so on. So this is a tabular representation of this even number. Now if I write the same set using symbols, say 2x, such that x is a natural number, you can use other symbols also, we will discuss it later. So x is an even number and the elements are 2x. So if you put x equal to 1, this will 2, x equal to 2, this is 4, x equal to 3, this is 6. So this is an even number set. These two sets are equal, these two sets are equal, but this representation is set builder representation. Okay, so this is how you represent your sets. Now there are few symbols like we often use in the set, like this. This refers to belongs to. Okay, this refers to does not. Okay, does not belongs to. Fine. Now what is this to? Suppose this is a set A, B and C. Okay, so the name of the set is suppose capital A. Then it is clear that A is a member of capital A, small a is a member of capital A. So I can write A belongs to capital A. If an element is a member of the set, then we used to write that particular element belongs to A. Now D is not a member of A, so I can write D does not belongs to A. Okay, So these are two symbol of belongingness and not belongingness. Now come to types of sets. Okay, what are the types of sets? First is empty sets. Okay, what is empty set? A set containing no elements. It's too rough. A set containing no elements is called empty set. Okay, now what are the empty sets? There are many empty sets, like suppose x such that x belongs to real number. We use this symbol as real number, the set of real number. X is a real number and x square plus 1 is equal to 0. So this is a empty set because x square plus 1 has no roots in real set. Okay, x square is equal to minus 1. So x square has no roots in R and therefore this set is empty. One more example I can give. X such that x belongs to natural number and 0 less than x less than 1. This is again empty set because between 0 and 1 there is no natural number, so this is empty. Okay, I can give another example. X such that x belongs to z. Z is the integer such that two x plus 3 equal to 0. This is again an empty set because what will be the 2? So that 2x plus 3 equal to 0, it is clearly minus 3 by 2. So this x is nothing but, this set is nothing but, this set contains only one element, that is minus 3 by 2. But when you ignore this one, if x does not belongs to z or x belongs to R, then this set contains this single element. But here we are considering x belongs to z and this element, this particular element minus 3 by 2 does not belongs to z. Okay, it means this is nothing but empty set. Okay, you got my point. If in the place of z, if we write R, then this set contains only single element minus 3 by 2. But as this x belongs to z, it has no elements. Okay, so this is an empty set. Next is your finite set. Now what is finite set? A set containing finitely many elements. Okay, so the set containing finitely many elements is called a finite set. Now what is finitely many elements? Means you can list the elements A, B, C, D, 1, 2, 3 like that. You can list the elements. If you cannot list the element, it is not finite. Here comes list the element, means you can list it and you have to finish it. Okay, you cannot put dot dot dot. You cannot put dot dot dot. Here dot 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 means you can list it, but you have to finish it. at some point. So you have a finite number of elements. If you cannot finish it, it means the set is infinite. Here comes our next type of set, that is number 3, infinite set. Okay, infinite set. Infinite set, a set which is not finite, okay, is called infinite set. Not finite, it means it will you go on listing the elements. Okay, even if you cannot list the elements, it is infinite. Okay, so some elements that you can list, such as the set of natural number, that is, you can list 1, 2, 3, 4 and so on, but you cannot list the set of real numbers. This is also infinite. Okay, these two sets are infinite sets. There are many sets that you can design which are infinite sets. Okay, so this is infinite set. Now it means we can count the number of elements. So here comes the next definition, that is cardinality of set. Now what is cardinality of set? It is the number of elements in the set. Okay, the number of elements in the set is called the cardinality. Cardinality of the set. Okay, so this is cardinality of the set. For example, if you want to understand, suppose 1, 2, 3, 4, 5 and 6, and this cardinality, suppose this set is A, then cardinality is nothing but 6. Okay, this cardinality is 6. If I say n natural number, then the cardinality here, in case we do not write this, but we say this is infinite cardinality because the set is infinite, so its cardinality is infinite. Okay, so next term that comes from the cardinality, that is equivalent set. So what is equivalent set? Two sets A and B are equivalent if their cardinality is same. It means mod A is equal to mod B. Means if the cardinality of two sets are same, then these two sets are called equivalent sets. Okay, even if the sets are not equal, means same, its cardinality may be same, and in that case they are equivalent. So this 1, 2, 3, this is also has 3 elements, this is also has 3 elements. These sets are called equivalent, means we can write like this: these sets are equivalent because of their cardinality. Okay, now comes to the next one, that is equal sets. This is our last topic today. Equivalent set. Now what is equivalent set? Consider two sets A and B. Sorry, not equivalent set. We have to do equal sets. Equal sets. Okay, two sets A and B are said to be equal, that is A equal to B, if we satisfy two conditions. What are those? First, they must be equivalent, means the cardinality must be same. Second, all the elements are same. Means elements must be same. If there is ABC, then in that set also we must have ABC. In that case we say set is same, because the cardinality is also 3 and elements are also same. Okay, so this is called equal set. So here we